Welcome to qnawire.
Our question says that the script for an action movie calls for a small race car of mass 1,500 kilograms and length 3 meters. We're going to refer to this as M1 to accelerate along a flat top boat of mass 4,000 kilograms and length 14 meters. We're going to call this body 2. And from one end of the boat to the other, where the car will then jump the gap between the boats and somewhat lower deck. You are the technical advisor for the movie. The boat will initially touch the dock as in figure 9-81. Okay. And it says that the boat can slide through the water without any resistance, so ignore friction, and both the car and the boat can be approximated as uniform in their mass distribution. Determine what the width of the gap will be just as the car is about to make the jump. Okay, so we're going to treat the car, the mass M1, as a point mass, which is initially 1.5 meters to the right end of the boat. The left end of the boat of mass M2 is initially at the origin, we're going to call it 0, where the dock is, and its left end is at a position of 14 meters, right? Because it's 14 meters long. So the boat's end of mass in the absence of the car is initially at 7 meters. So we're going to use equation 9-5 to calculate the center of mass of the system. So here we have, right here, x center of mass, we're going to call it Cm, is equal to M1 x1 plus M2 x2 divided by M1 plus M2, which is equal to M1 is 1,500 kilograms. And then x1 is the length of the boat, which is 14 meters minus 1.5 meters. And then M2 is 4,000 kilograms multiplied by x2, which is 7 meters. Then this is going to be divided by 1,500 kilograms plus 4,000 kilograms, which is 5,500 kilograms. Okay, plugging all of this into your calculator, this comes out to equal 8.5 meters. Okay, so in the absence of external forces, the center of mass of the system does not change. So later when the car is about to make the jump, it's near the end of the boat, which has moved from the shore by an amount, we're going to call it delta x. The value of the system's center of mass is still 8.5 meters. And the car at this moment is thought to have a point mass 1.5 meters from the left end. So we must have a new center of mass, which we're going to write here. We're going to call that x center of mass here, prime, which is equal to the x center of mass that we just calculated, which is going to be equal to M1 times delta x plus 1.5 meters plus M2 times delta x plus 7 meters divided by M1 plus M2. Again, M1 and M2 are 1,500 kilograms and 4,000 kilograms respectively. So if you solve for delta x, you find that delta x is equal to 3 meters. We can box it in as our solution.